Good afternoon. Lesson 2-1, direct variation, is what we're going to go over today. When two variables x and y satisfies the equation y equals k times x to the n power for some constant value of k, we say that y varies directly as x to the n power. Now, you should remember in Algebra 1 we dealt with equations such as like this. Y equals 3/4 x, where 3/4 is our direct variation, constant, and so forth. Obviously, x is to the power of 1. But what we're going to deal is with problems where we ain't going to know the constant variation. You have to find it, and we'll go from there. When possible, Lance puts his bike into its highest gear for maximum speed. The highest gear, the ratio of the number of front gear teeth to the number of back gear teeth, is 52 teeth divided by 11 teeth, which is approximately 4.73. This means as Lance turns his pedals one complete revolution on his bike, the back wheel turns almost 5 times. So if W is the number of back wheel turns per minute, and P is the number of pedal turns per minute, then what we would say is W is equal to 52 divided by 11 times P. If Lance starts pedaling twice as fast, then the back wheel will also turn twice as fast as it previously did. We say that W varies directly as P. And we call W equals 52 divided by 11P a direct variation equation. In a direct variation, both quantities either increase or they both decrease together. So as you notice, as it starts getting faster, more teeth are going to go. Therefore, they both increase in this situation. Suppose Lance changes to a lower gear with a gear ratio of 42 teeth per 21 teeth, which is equal to 2, 42 divided by 21. A direct variation equation for this situation is W equals 2P. Okay, notice how our constant of variation changed, just because we lowered it to a different gear. Recall a formula, area equals pi r squared for the area of a circle. This too is a direct variation equation. As the radius r increases, the area A also increases. In this case, A varies directly as r squared. Often this is worded using the area A varies directly as the square of r. Notice in this case, pi is our constant of variation. Okay? Pi is our constant of variation. Direct variation functions, the formulas, W equals 52 over 11P, W equals 2P, and A equals pi r squared are all of the form Y equals K x to the n power. K is the constant of variation. Okay? K is some non-zero constant called the constant of variation. And N is some positive number. Okay, 1, 2, 3, 4, 5, 6, could be anything. These formulas all describe a direct variation function. Okay, this is just it worded again right here. You may want to write that down. When y varies directly as x to the n power, we also say that y is directly proportional to x to the n power. For instance, the formula A equals pi r squared can be read, the area of the circle is directly proportional to the square of its radius. Here, n equals 2, that's our exponent, and the constant of variation is our pi. Okay, remember pi is just a number, 3.14, so don't let that bother you. Let's look at example 1. The volume V of a regular Alg2 hedron is directly proportional to the cube of the length L of an edge. Identify the dependent and independent variables and write an equation relating them. Okay? Well, the dependent variable is our volume. So A dependent is volume because volume is dependent on the length of the edge. So independent is the length. So what we're going to say is volume is equal to, and what it says is proportional to the cube of the length. So how do you say that? Well, our constant variable is k right now. And then what we're going to say is L to the third power. Why? Because it says it's cubed. We don't know our constant of variation yet. B says a regular icosahedron is a edge length of 4 centimeters, has a volume of about 140 centimeters cubed. Determine the constant of variation. So B, all I have to do is put that into this equation right here. So it says volume is 140 is equal to, we don't know K, but it says our length is 4 cubed. Okay? And what many of you should know, 4 cubed is simply 4 times 4 times 4, which is 64. Okay? So I'm going to rewrite this. 64K is equal to 140. And so we divide by 64. So K is going to equal 140 divided by 64 is approximately 2.19. I guess you could have said 2.2, but I'm going to go out 2 decimal places. So 2.19 is my constant of variation. C says write the variation equation using your result from part B. Well, C is going to say then C is, V, and all we do is just put in our constant of variation into this equation. 2.19 L to the third power. D says approximate to the nearest cubic centimeter the volume of an icosahedron with an edge length of 5 centimeters. Okay, so all I have to do is put 5 in for L. And so 5 times 5 times 5 is 125 times 2.19. You all are going to tell me is 273.75 centimeters cubed, because we're talking about volume. And all I did was put 5 in for my L. 5 times 5 times 5 is 125 times 2.19. And I get my volume of that object. Moving on. Example 2. Says suppose B varies directly as the 6th power of G. If B equals 729 when G equals 2, find B when G equals 10. Okay? It says B varies directly as the 6th power of G. So this is my dependent. So B equals, we don't know our constant of variation yet. We'll find that in just a second. The 6th power of G. So G to the 6th power. Okay. So I got my equation. I'm going to use these two things to find my constant of variation, my k. 729 is equal to k times 2 to the 6th power. And you all are going to tell me 2 to the 6th power is 64. And divide by 64. And my constant of variation is 729 divided by 64. 11.39. Okay. I always go out to 2 decimal points. It's just kind of whatever you prefer. Okay. Now that I got my constant variation, I'm just going to put that back in here. B equals 11.39 g to the 6th power. And what now that I have my constant of variation, and I know g here, it's going to allow me to find my b when g equals 10. So b equals 11.39 times 10 to the 6th power. Well, we all should know 10 to the 6th power is 6 zeros, which is a million, right? So all you're doing is taking a million times 11.39, and all that is moving the decimal point 6 units to your right. So it's going to be 1139. And then I need 4 more zeros. 1, 2, 3, 4. And that is your answer. B equals 11,390,000 when G equals 10. That's all I have for you today. Please take your time, find your constant of variation, plug it back into your formula, and then everything will work to your satisfaction. Thank you very much. We'll see you tomorrow.